Me?
Yeah.
What do you mean?
Huh?
What do you mean?
Caught up on your work.
Well, it's interesting you should say that.
What? You remember that? PSAT actually run to it?
No.
I didn't.
It's funny because I walk in and Townsend says, "Are you all caught up?" And I'm like, "What?"
It might be
All
pretty
caught up
good
on
if you
your
don't
work.
need any help. Oh.
No. How did he know? I just need to be
Do I get an extra? No, I just don't like bowling.
I need like my head to be put into a hydraulic.
I actually crashed out so bad last night.
You will learn to like it before it goes away.
Yeah, what do you
So.
do?
Really?
Yeah, you have to.
I was
That's
already
one
on
of
the way
way.
to crash out. And well, I could learn to be good at it, so I like it or something.
Okay, that's fair.
And he was like, I only code once. I was like, me too. And you know it's this whole thing. I got like my first and pretty much all my classes was in Spanish too. I got code for a week. And he graded all my assignments at 0 right before the quarter. I'm like, shit, and so I crashed out because I started like writing and tweeting about that grade. That was like 4 years ago. And then I just started crying.
Because my parents made me.
Yeah.
They're like, yeah, that's
I've been
the
crashing out too. I've been staying up pretty
Hey.
late.
Eh?
I can.
Dude,
Yeah.
today, you know those toys that have like the really low center of gravity, but they're like round on the bottom, so you can like push them down and they like, that's how I feel right now, like physically.
It's kind of fun.
I love the show. Fantasy Wars.
Like,
Okay, yeah.
Just play with the toys.
I don't, I low-key think I'm just gonna start being a bum.
I gotta find a good balance of like being a bum and not being a bum.
Well,
Like you
that's
can't be
kinda
stressing
how
over
I-
one assignment, bro. It's just
That's how I was all of this year and last year, but I think I just wanna be a person. I decided I'm not gonna go to college. I'm just, no, I actually have a plan this time. Usually I say that, but I'm just saying it. But this time not what I'm saying. Like, I don't want to apply. I don't want to apply.
And they're-
If you don't wanna apply to college, apply to University of
I don't
Arkansas.
want to go to
Yeah,
UArk.
apply to
So what I'm gonna do
Joel,
is
Alan,
nothing.
Lane G, you
Lane, Rebecca,
What?
This,
Hayden.
nothing. So you also.
Okay, guys, I need y'all to get out this assignment from last class, and I'm gonna give you a chance. We're not, obviously not gonna have time to do full period words and stuff, but I want to at least take your questions from this. So I'm not gonna have you move in to the third part today, but I need this part to be done. So, if you don't have questions, if you stuck with the assignment well enough to finish it on your own, then I guess this is a free period for you.
Do we have to turn in this assignment?
Depends on what questions y'all have.
How to do it?
Well, you should have asked those questions last time.
Are we asking? I don't know. I'll just
Yeah,
think
yeah.
about it. Talk about it tomorrow.
Now, you
Okay,
can't,
if we turn it in unfinished and then turn it in when it's finished, do we get a 75% grade?
that's correct.
Really?
What if
But
we
also,
weren't-
don't cut any corners on this, because this is only the second session in the section, and the third section is the same stuff again, so.
I know, I just haven't had much time to go over it yet.
What if
We just had a 4-day weekend.
What if we weren't here one of the days we had a work?
One of the days, you have to be more specific.
I wasn't here last Wednesday when we worked on this.
Yeah, I wasn't here when you taught it.
Yeah.
Okay, well, you get 2 days when you miss. The number of days you miss plus 1. You shouldn't wait a week to figure out what you need to do. It's been a week since I've seen y'all.
Yeah, I'm rusty. I
2 business days or? I don't care. Just take the hit.
I mean, I am, but it would be. Never mind.
Okay, let's get started, please. Okay, Leah, what do you got?
Can you please go to number 7?
Number 7.
I have some issues.
Sure.
He's such a.
Okay, number 7, write but do not solve. So it could be, unfortunately with these, there's oftentimes more than one correct way that will work. So it's possible that we could come up with a way that just doesn't look like their answer. So I don't know if that will be a problem or not. But we need to find the area enclosed by one petal of the 3 petaled rows r equals 4 cosine 3 theta found in the first and fourth quadrant. Okay, well the fact that they told us to focus on the one in the first and fourth quadrant probably means that there's only one answer to this. Okay, so in this section, I realize finding the angles is pretty difficult, but everything else should be pretty easy. If you want to find the area of a polar curve, there's a formula. Area is 1/2 integrate alpha to beta r squared d theta. And the only part of the formula that's hard to find are the 2 angles. Now this one especially, because sometimes you're going to have access to a calculator and you can just graph it in your calculator. Sometimes they're going to graph it for you and give you a visual. But in some instances, not all the time, but occasionally, we need to know kind of what this graph looks like to know these angles. If you're just hoping that you know what these angles are, like the only way that you even reasonably could do that is if you have a very good idea of what this graph looks like. And that only comes from lots and lots and lots of practice, which we just don't even have time to do. So, did you try to make a graph of that?
I plotted some points, but they weren't helpful because they were in like a different column.
Okay. Well, I don't know that any point's not helpful, but if you want to know what the graph is, more points is always going to be better. So if I just start plugging stuff in for theta that I can do easily on the unit circle, if I plug in 0, I get 4 times 1. So in the 0 radians direction, You should have gone 4 to the right. In fact, I don't remember if I emphasized this a lot with y'all or not, but if you label these points, I think you're going to see why this is going to make it a little bit easier for you to understand the graph. Okay, did you get that point?
Yes.
Okay. Now, you can just pick random angles, but honestly, this is a little bit easier to follow if you pick the next biggest. So I pick 0. I don't want to pick, I don't know. I don't want to pick something that's going to give me like cosine of square root of 3 over 2. No, it's the same handout from last class. I'm just taking questions. I want to plug in an angle that times 3 I actually know the cosine of. So something like pi over 6 is almost 0. Times 3 is pi over 2. The cosine of pi over 2 is 0. Times 4 is 0. So in the pi over 6 direction, it's already to 0. Now, I didn't mean to do this because I don't know what this graph looks like. But this is why I say it's helpful to label them and to maybe do these in order. Because if I start at this point, and then I barely turn it all, and it's over here, then this must be doing something. It must be going to that point very quickly. There's not only the angles between 0 and pi over 6. So that's probably half of that pedal. I say probably. The other half's this way. So let's say if this is 0, what could I pick to maybe go backwards and hopefully land at 0? Exactly. If we know this much of a turn is pi over 6, then there's not a guarantee, but there's a good chance this amount of turn is pi over 6. It's just going in the negative direction. So let's see. Negative pi over 6 times 3 would be negative pi over 2. Cosine of negative pi over 2 is 0. Times 4 is 0. Okay. Well, that was extremely lucky. Lucky because I picked out very helpful points, and that doesn't always happen. Sometimes you need lots more points. It doesn't hurt to get the points. I think if the rest of the graph probably looks like this if you keep getting points. But in the end, negative pi over 6 starts here, 0's there, positive pi over 6 is here. That's what gets you all that. Negative pi over 6 to positive pi over 6. So, is that how they wrote their answer?
Yes.
Okay. So, again, you guys are always going to have the same 2 or 3 issues with each question. Either A, you don't know what the graph looks like. I'm going to say do more points. B, you're missing some of the points because of unit circle mistakes. I can't help you with that. You just have to slow down and do your best. And you need to know the formula, I guess. But most of the discovery is about trying to find those 2 angles. Yes?
When you're guessing, you're like putting in numbers for theta.
Yeah.
Are you trying to find when r equals 0 or just like a repeated number?
That time, I was just trying to find anything.
Okay.
But sometimes, yeah, sometimes I know, like on this question, and I don't know if you guys will ask about it, but on this question, I can see where I want the area to be. So like, I might be interested where, well, maybe that's not a great example. Like, let's say that this area just went to 0 or something. I might be interested at starting when r is 0 in that case. So you're right. I might plug in 0 for r and solve this to figure out what that angle is. Both are viable solutions. Sometimes you want to plug in 0 for r and solve to see where it's hitting the origin, what angles it's hitting the origin, and sometimes you just want to plug in points. One of those is not sufficient. You've got to do a little bit of both. Okay, Leah, was that enough?
Yes, sir.
Okay, was anybody else going to ask about number 7? Okay, somebody else have another? Derek, no questions?
Or 8?
You're the only Derek, yeah?
I finished.
Okay.
For 8, how do you set up the equation to where you're only finding that shaded region? Does that depend on the bounds then?
Yeah, it's gonna come down to the angles. Basically, and I can go through it, but basically you're gonna pick out an angle, pick out another angle, pick out another angle, and then eventually you're gonna find this spot. It's probably pi over 2 because it's straight up, but there's no guarantee. But then you're gonna know the formula is 1/2 alpha to beta r squared d theta. So probably this is the starting angle and this is the ending angle, and if you can figure out those angles, then your answer comes from that. Like, sometimes y'all, well, let me go ahead and finish. So y'all are making this harder than it needs to be. So if this is probably pi over 2, how do I know for sure if this angle is pi over 2?
You could set the r equal to that, like, the r on the graph, you can set it to that equation.
Like you're saying plug in 1 for r?
Yeah, like so, yeah.
Now you can, but one thing that you need to be careful of is r can be negative. So if r is like -2, you just go in the other direction too. Why not just try pi over 2? If I plug that in, what does r equal when I plug in pi over 2? And in the pi over 2 direction, isn't it traveling a distance of 1? Okay, so there's where the area starts. There's the bottom piece of my integration. And then I could pick a bigger angle, like maybe pi, and I would get 3. So here is 3 pi. I can see I got to get a bigger angle, so I could guess something, but maybe make an educated guess. Your educated guess is this angle is probably 3 pi over 2. And if I plug in 3 pi over 2 and get 1, 2, 3, 4, 5, if I go 5 in the 3 pi over 2 direction, then I'm right about that being 3 pi over 2. It's not just a guess. That would be 3 minus 2 times -1, which is 5. So throw that in the calculator and there's your answer. The only thing hard about polar is finding these angles. The formula is the same every time. 1/2 integrate alpha to beta r squared d theta, and r is going to be given to you. So, okay, Leah, what was your question?
You answered it,
Oh, I did. Okay.
but I have another.
Yeah, just one second.
So, for 11,
Okay.
I don't really understand why we put a, as one of the bounds. I don't know, I just didn't really understand how to start 11.
Okay, so
And it's a pretty easy question once you like start it.
yeah, so if it asks area of a polar curve, again, 1/2 integrate alpha to beta r squared d theta, you really just have to figure out what alpha and beta are to get this enclosed area. So if theta is k and r is this, I'm going to say that they probably started with 0. Is that correct? Okay, and then what angle, so I started this, oh wait, actually, do I need to subtract? Okay, so if I do it at 0 to, what is this angle? Isn't this just their k?
Yeah, I didn't
Let me see how I did it. I remember it not being a difficult question, but
Like if you know that it has to be in terms of K, don't you know that one of your bounds has to be K? If you know that your integral has to be in terms of K.
Oh yeah, if you want your area in terms of K, then we do have to have this in terms of K. So that would be,
No, it's like then you know that your bound has to be in K.
yeah, you're right. Okay, so what I did is I used these two, and I said if theta is K, then R is K over 2. So over here, instead of saying theta over 2 squared, I said K over 2 squared. No, I did not. I did not do that. I did... Bless you. Okay, so this point is 0, 0. 0, R in the 0 direction. This point is K in the theta direction. So the angles that I want to integrate from are 0 to K. That's where they got that. And oh, okay. And then R squared would be, let me write it like this. R squared would be theta squared over 2 squared, which is 4, theta squared over 4. So you could call this theta squared over 4. But this 1/4 is really just a constant. So if you want to pull the 1/4 out, you can. And then that's what I worked with. So I got 1/8 times the antiderivative of this from 0 to K. So 1/8, oops, 1/24 K to the third, and then if you plug in 0, you get 0. So K to the third over 24.
I just don't understand why K is one of the bounds. Like, wouldn't a bound be K over 2 if it's R followed theta? And I know like yours was right, but I just don't.
Well, you don't want a variable as one of these bounds. You need the bounds to be numbers. So if you have this, if you have an R in your bounds, that's a problem. K is just K doesn't work like R because K is a constant. So it's just a number, and that's why it's okay to do that. But you shouldn't have R's up in here.
It's saying that, like, hypothetically, if K was a number that we knew, we would just put that number in for K there, and then you would get like a real number.
Yes. Yeah, most of the time you have a real number there. They're just trying to make K be generic. Okay, give that one a second look and then maybe narrow down exactly which part that's not making sense, and then I can try again. Okay, 13, 29. Okay, we still got almost 30 minutes, so let me answer those other questions and I can try this one again. Joel, no questions for 9.8? Not at all. Alan, no questions?
I answered mine last time.
Will? Okay. Do you have another one, Leah? Now's the time to get help on them, because again, next time we're doing area bounded by 2 polar curves. So you basically have to do like 2 of these in one question. So.
Because I don't get why you just can't set the bounds as 0 to pi.
Okay, so if you do 0 to pi, so if you do 1/2, 0 to pi, r squared, it looks like that. The problem is, or I'm assuming because I don't know, at 0 radians, if I plug in 0 up here, r is the cosine of 0, which is 1. So you're talking about this point.
Okay.
And then at pi, I plug that in, cosine of 2 pi is 1. So you're talking about this point. Those points don't help you get that area at all. They don't hurt anything, knowing that this is 1 in the 0 direction, still something. And then I can try other stuff. I could try something a little bit bigger, like, how about pi over 6? 2 times pi over 6 is pi over 3. The cosine of pi over 3 is a half. So in the pi over 6 direction, it goes a half. And now notice, if I start plotting these points, 1/2 in the pi over 6 direction, I can kind of see the direction the graph's taking. Here's 0, here's the next biggest angle that was going to be easy to work with. So the next biggest angle that's easy to work with is probably going to get me to here. That's my guess. So maybe pi over 3. Cosine of 2 pi over 3 is -1/2. So I was wrong. In the pi over 3 direction, it goes -1/2. So again, it sounds like this doesn't have anything to do with finding the shaded area, but I'm getting closer. 0 radians, pi over 6 radians, pi over 3 radians, and as I keep making these angles get bigger, eventually I'm going to start and end, and then I'm going to know which two I need. So, I don't know, a little bit bigger could be pi over 2, which is the same as cosine of pi, which is -1. So in the pi over 2 direction, it goes to -1. Notice, here's an example of r that you were worried about, Lana. Pi over 2 is this way, but since r is -1, it goes the opposite direction and plots 1. Okay, that's pi over 2, so if I make it a little bit bigger, this is pi over 6, pi over 2, how about 2 pi over 3 might be the next biggest one I could do easily. Times 2 is 4 pi over 3, which is -1/2. So in the 2 pi over 3 direction, which is this way, it goes -1/2. Okay, so again, if you're labeling these points, it gets more and more obvious which angles you need. Here's 0, pi over 6 only got me to about here. Pi over 3 was to about here, I just accidentally erased it. Pi over 2 got me to here. 2 pi over 3 got me to about right here. I'm getting close to the one that I want. So my next biggest is probably pi. Okay, so when theta is pi, I would get cosine of 2 pi, which is 1. So in the pi direction, it goes 1 in the pi direction, so that's that point. Okay, wait, so I just went too far. I should not be using pi in my answer then, because that would be right here. I don't want to start or end my area here. I want this to be in the middle. I need this back here. So something between 2 pi over 3 and pi, that could give me 0. So I had skipped over 5 pi over 6. I guess I could try that. Times 2 would be 5 pi over 3, which is a half. So a half in the pi over 6 direction is right there. So 5 pi over 6 is a little bit too much too. So it's something between 2 pi over 3 and 5 pi over 6. What have we not tried?
Two-thirds pi.
That's 2 pi over 3. Pi over 4, okay. Okay, pi over 4 is probably going to be back here. Let me try 3 pi over 4. Because 3 pi over 4 is between 2 pi over 3 and pi. So, times that by 2, you get 3 pi over 2. The cosine of 3 pi over 2 is 0. That's good news. Finally, and again, this is what happens to me too. I'm not taking any shortcuts, what's the opposite of a shortcut? A long cut? Huh? It's not really a detour, because all this was helpful. But there's no quick, I mean, you can make educated guesses about those angles and narrow it down, but I'm saying this is worst case. I started at 0, plotted the point, made the angle a little bit bigger, plotted the point, made the angle a little bit bigger, plotted the point, and made another angle, plotted the point. I figured out it's got to be between these two angles, and then finally, and I wasn't trying to make this take a long time, but finally I figured out that it's right here. That area starts getting enclosed at 3 pi over 4. If I go to pi, I've done half of it. So if this is 3 pi over 4 and this is pi, 0 in the 3 pi over 4 direction, how much do you think we have to go till we go back to 0?
5 pi over 4.
Okay. Times 2 is,
I don't know.
well, you're trying to be smart. So here, 5 pi over 4 times 2.
5 over 4.
5 pi over 4 times 2.
I think Derek can answer that one.
No.
He's got other questions coming.
You want me to just
5 pi over 4 times 2.
10 pi over 4.
Times 2.
Okay. Can you do someone else? I'm actually getting embarrassed.
5 pi over 2. And the cosine at 5 pi over 2 would be 0. Yes? Which is what we thought it was. So all of that to figure out, like I said, is the angles that can potentially take a long time. All of that to figure out that that highlighted petal was between 3 pi over 4 and 5 pi over 4. It's okay if you don't get it in the first 2 minutes. It just means you've got to try more angles and box it in a little bit. Now, there is one other thing I want to say about this, not a joke. Referencing what you were talking about earlier, Lana. Like, you see how this area started and ended when R was 0? So you can do the table thing, and I thought the table thing was going to be the most useful. That's why I did that. But you could have also said, if this is the equation, and I know that my trapped area starts and ends when R is 0, you can solve that equation. There's 2 times where cosine is 0, pi over 2 and 3 pi over 2. But if I'm going to multiply that by 2, this would be like pi over 4 and 3 pi over 4 makes that true, and 5 pi over 4 makes that true, and 7 pi over 4. Actually, I don't even know if that's true. I'm just making stuff up now. But anyway, you can solve, I think that's right. You can solve that because there's lots of answers to this. So you could notice I ended up picking 3 pi over 4 and 5 pi over 4. But you still have to do a little bit of thought into why not pi over 4, why not 7 pi over 4. They're not part of the right part of the graph.
So would you say the table method is like the best way to approach it?
I think it just depends on the question. It depends on the equation. you're trying to, like, depends on what r equals and how hard it is to solve for 0. It depends how many times r could be 0. In this question, r is 0 1, 2, 3, 4 times just in one rotation. So that makes it harder, because if it was only 0 twice, and that's the 2 times I needed it, I could have just set it equal to 0, solved, and been done.
So then, could you do that to 10? Without 110?
Okay, that's exactly what I would do. I wouldn't just be guessing angles here, because there's only 2 times where r is 0. There's only 2 times where r is 0. So if I can figure out where those 2 times are, I am that close to being finished. I just need to figure out those 2 angles. So if I plug in 0 for r, subtract the 4, divide the -6, you would get sine is 2/3. Does 2/3 sound like a ratio from the unit circle? Okay, I'm not asking you any more unit circle today. 2/3 is not something we memorize on the unit circle, but you have to realize when we memorize the unit circle, we memorize these quadrantal angles and then like 3 angles per quadrant. There's 360 degrees. We don't memorize hardly any of the unit circle. We just memorize some of the most important parts. So I can't ask you what angle gives you a sine of this, because you don't memorize that. But what you could do in your calculator is you could ask it what is the inverse sine of 2/3, which is your way of asking the calculator what angle has a sine of 2/3, and it's going to be some weird decimal that we've never heard of before. 0.730. Actually, that would be where it started. That would be the first time. Okay, so there's one time where sine is 2/3. Where's the other time?
Pi minus that.
How do you know that?
That's the answer she says.
I know, but why does the answer sheet say that?
Because there's 2 places where sine, where that.
Okay, on the unit circle, sine values are the x values or the y values. So if you can figure out an angle, like this guy, where the sine is 2/3, where's another angle where the sine is 2/3? Right, the other place where y is 2/3. Sine is the y value. So that angle is pi, take away this angle, which we happen to know this angle is 0.370. So that's where the 2.412 came from. Good? So the first part of your question, yes. The second part of the question ended a little differently, but. Okay, how are we on time? We've got about 15 minutes left. Is there anybody who has not had a chance to ask a question? I'll give you a chance. Okay, then others, what else you got?
For 12B, is it just a critical number?
12B. It's like extreme value theorem.
Okay.
Test the endpoints, test the critical numbers. Whichever one gives you the biggest value is the biggest distance, because R represents the distance from the origin. Now, the catch there, I don't know if you've done that question or not. The answer to that question actually has R as a negative number, but that's still the biggest distance. So don't think just because R is negative that it's smaller. It's just the negative tells you direction, not length. So. Okay, sounds like a few people might still be working on this and might find some more questions. Again, I know you guys only have about 15 minutes, but I will be taking this up when I see you on Friday. So you've got a little extra time. Make sure you put in a good effort. Questions that you missed, you might try some of them a second time. At the very least, come up with a list of things that helped you finish some of those questions. Because again, I don't want the last section to become impossible to you, but you've got to be able to do this to do that. So. Yep. Oh, my bad. I get it fixed. Get it back. Thank you.
I won't be here Friday for bands. Do you want me to just turn into?
Yep, sure. I'll bring it back in a minute. What is band doing on Friday?
We're leaving for a trip over the weekend for a competition.
She doesn't know the beats.
Can't y'all just compete with each other? Yep. Oh, that was the last of your questions?
Oh, yeah.
Yeah, I'll look back at that one, because I have it down, but I remember it not being too hard, but yeah, I also wasn't sure when you asked. I'll look back at it.
I'm sorry, it's just very.
Why are you sorry?
Challenging for me to.
No, this is hard for a lot of people.
Yeah, I hope that you enjoy grading this, 'cause there's like red marks all over it.
Y'all be surprised. By the time we get around to a quiz, y'all will be a little better at it than you.
No, I can't.
Yeah, I don't know if it's quite great.
What do you think about this, Mr.
Yeah, it makes it a lot more fun.
Yeah.
Can I help seriously? Or are you not going to
I don't know the. I think just let me try a little bit.
Well, it was open as well to do.
I did everything else.
No, you're part.
I told you that Joe actually
I'm just
played.
starting. I didn't know.
I've been focused on my college essays.
Shut up!
Was it like a speed run? Was it like a speed run thing or? Oh. How long did it take you now?
Dinner. Meeting, and then.
You are not welcome to keep my copy, but if you want to see the schedule today, you're welcome to look at it.
The notes copy?
Yeah, do they have a swimming pool?
Oh. Are those new jeans?
But Boston might say no.
You better not.
He said it for Disney.
Water bottle?
No.
No crackers?
Really?
Yes.
I did.
Technically. I was just wondering. Oh, would you mind scrolling up to the notes now?
I mean, I don't know, are you applying for honors college?
Maybe that more than I do.
I don't think
Um,
I'm qualified.
Okay. It's just kind of showing you where the formula comes from. You won't have any questions about this, but basically you just take the geometry formula that you probably never learned, area little tiny slices, do an infinite, add them all up, do an infinite number of them, and that's the definition of integration, so we really need to get down to that.
Yeah, that was the only thing, I did see there was a back. That's only honors college.
No, it's something, it's not anything I would know.
Yeah, I mean, that's honestly. I know like I won't be set through the whole deal. And it's not relevant to but like other than that.
Like Kevin. That's not what I asked.
Well,
When did I ever say carbon monoxide?
Did you hear those words come out of your mouth? You just make this.
You were asking to be more effective. Melatonin or caffeine, I said most effective.
That's not what we asked.
I can't really access carbon monoxide very easily, can I?
No, our garage is like open plan.
My garage is.
You go, okay, then go on a project.
That would not be nice.
Yeah, that's what we're trying to do. They have like warnings about it in the code. They drop the letter. People wait for the caution.
I think
Okay, but
that
if
would
we were to
probably
choose
just
between
swag.
Which, okay, are you asking which is more effective or which would be more? Which would be better?
which you would choose.
Oh, which would I choose from? Would you choose caffeine? You just
I
like.
don't know,
like,
I don't think
hypothetically-
about this a lot, Harper.
Hypothetically,
Do you think about this a lot?
yeah, I saw the gap though. I saw the vision. That's what I would have done. I would have blasted it over every time.
It's like 400
It's not the
milligrams.
play, that's what I would do.
I don't have your 9.7.
Oh,
It's not here. You did keep going down the line, like you did.
Polar.
What do you mean you are me in polar? But this is a polar sign.
Cause, okay, just think about it. If, like, our.
I don't know, I'm always trying to think about
Caffeine at a
this.
certain point out, you're drinking enough, like, yourself, you're actually gonna be going.
It's so fun.
Well, the
Okay.
thing is,
Until you die. Yeah, when you play something that's good, then like it
Imagine
doesn't
like-
work.
1 equals I.
But like when
Yeah, imagine.
looking up a forehand right at the ball dude's face is so fun.
imagine you like waiting for
Okay, yeah, imagine. It's the same argument that goes for caffeine.
I did that.
It's organic.
Yeah.
As long as you take enough milk.
I got a stack of things.
Our detector used to this.
What?
I got
You wanna take a projectile? This,
Do you ever make it?
It's just a hypothetical.
yeah, it's a stupid hypothetical.
Okay, you hate this thing, which is he hates you.
Yeah,
Like,
bro, everything is so close. Like, yeah.
I would do carbon monoxide, or I would dump that one.
I feel like that would suck.
And then
Also, you have like, they're like certain things. Yeah, like certain things and stuff.
I feel like when you
Yeah, but if you get
just
like
like
one.
stupid.